You've probably heard that phrase in the news, usually in a serious tone, often tied to global tension or nuclear weapons. It sounds like a red line, a point of no return. But what does that number actually mean? To understand it, we need to start with uranium itself. Uranium, as it exists in nature, isn't uniform. It's made up of different isotopes, atoms of the same element with slightly different masses. The two main ones are uranium-238 and uranium-235. About 99.3% of natural uranium is uranium-238. Only about 0.7% is uranium-235. And that tiny fraction, less than 1%, is the important part, because uranium-235 is the isotope that can sustain a nuclear chain reaction. That's where enrichment comes in. Enrichment is the process of increasing the percentage of uranium-235. So when we say uranium is enriched, we simply mean that the concentration of uranium-235 has been increased above its natural level. Now, let's talk about that number, 90%. When uranium is 90% enriched, it means that 90% of the material is uranium-235. That's all the number represents. But getting there is anything but simple. Enrichment isn't a linear process. You don't just scale up from 1% to 90% in a straight line. Each step involves separating isotopes that are almost identical in mass. It's technically difficult, energy-intensive, and requires highly specialized equipment. And as the percentage increases, the implications change. At low levels, around 3 to 5%, enriched uranium is typically used as fuel for nuclear power plants. At around 20%, it can be used in research reactors. At higher levels, like 60%, it becomes much more sensitive from a global security perspective. And at around 90%, it reaches what's commonly called weapons grade. That's because at this concentration, uranium-235 can sustain a fast, uncontrolled chain reaction, the type required for a nuclear explosion. But here's something that often surprises people. The hardest part of enrichment isn't going from 60% to 90%. It's going from natural uranium, 0.7%, to the first few percentage points. That early stage requires processing huge amounts of material and doing the bulk of the separation work. Which means that once a country reaches higher enrichment levels, much of the technical challenge has already been overcome. This is why experts focus on something called breakout time, the amount of time it would take to produce weapons-grade material if a decision were made to do so. Once enrichment reaches higher levels, that time can shrink significantly. So how is uranium actually enriched? The most common method today uses machines called gas centrifuges. First, uranium is converted into a gas. Then it's placed into a centrifuge, a device that spins at extremely high speeds. Because uranium-238 is slightly heavier, it moves outward toward the edges. Uranium-235, being slightly lighter, stays closer to the center. The difference is incredibly small, so a single centrifuge doesn't do much. That's why thousands of them are connected together in sequences called cascades, each stage gradually increasing the concentration. This technology has evolved significantly since early nuclear programs, including efforts like the Manhattan Project, which relied on far less efficient methods. Modern centrifuges are compact, efficient, and capable of producing higher enrichment levels more quickly. Now, there's an important misconception to clear up. 90% enriched uranium is not a nuclear weapon. It's a critical ingredient, but it's only one part of a much more complex system. Building a functional nuclear weapon requires advanced engineering, precise design, and delivery mechanisms. Enrichment alone doesn't equal a weapon, but it does represent a threshold, a point where the same material used to generate electricity can, under the right conditions, be used for something far more destructive. So when you hear 90% enriched uranium, you're not just hearing a technical statistic. You're hearing about a level of capability, a stage in a process where the line between civilian energy and military potential becomes much thinner. And understanding that distinction is what turns a headline into something much more meaningful.